We are on the brink of a materials revolution. Imagine a world where materials could heal themselves like a wound closing up. This is the promise of self-healing materials, a fascinating frontier of materials science. These materials have the incredible ability to repair damage and increasing durability and longevity. From everyday items to spacecraft, self-healing materials could revolutionize our world. Self-healing materials are not science fiction. They are rapidly becoming a reality with the potential to transform industries and enhance our lives. Picture self-healing phone screens that erase scratches or bridges that repair cracks caused by earthquakes. The possibilities are endless. As we explore the captivating world of self-healing materials, we will uncover the science behind their remarkable abilities. Join me on this journey as we examine the potential of these materials to shape a more resilient future. It is a future where materials are no longer passive, but active participants in their own longevity. The magic of self-healing materials lies in their unique internal structures and chemical compositions. These materials are designed to mimic the remarkable regenerative capabilities found in nature. Think of how a cut on your skin heals over time, or how a tree repairs damage to its bark. One common approach utilizes microcapsules, tiny spheres containing a healing agent. When damage occurs, these capsules rupture, releasing the healing agent precisely at the damaged site. This agent then reacts with the surrounding material, effectively sealing the damage. Another method involves embedding vascular networks within the material, similar to the blood vessels in our bodies. These networks transport a healing agent throughout the material, enabling it to respond to damage wherever it occurs. Reversible chemical bonds provide another pathway to self-healing. These bonds can break and reform under specific conditions, allowing the material to repair itself at a molecular level. This approach is particularly useful in polymers, where the broken bonds can easily reconnect, restoring the material's integrity. Self-healing materials are a testament to human ingenuity, drawing inspiration from the natural world to create materials with unprecedented properties. As we continue to unlock the secrets of self-healing, we open doors to a future where materials are no longer limited by their inherent weaknesses. Self-healing materials encompass a diverse range of applications. Polymers, metals, ceramics, and even concrete are part of this revolution. Polymers lead with microcapsules and reversible bonds. Metals repair cracks, ceramics withstand heat, and concrete uses bacteria. These innovations promise more durable and resilient infrastructure. The future of self-healing materials is bright and transformative. Please like and subscribe for more content. The potential applications of self-healing materials are as vast and varied as the materials themselves. Let's explore how these materials are poised to transform key industries. In construction, self-healing concrete can lead to longer-lasting bridges, tunnels, and buildings, reducing maintenance costs and improving safety. Imagine self-healing roads that repair potholes automatically, creating smoother and safer journeys. The aerospace industry can benefit significantly from self-healing materials. Self-healing composites in aircraft wings could repair damage from bird strikes or minor collisions, enhancing safety and reducing downtime. Spacecraft could utilize self-healing materials to withstand the harsh conditions of space, prolonging their missions and pushing the boundaries of exploration. The electronics industry is ripe for disruption by self-healing materials. Self-healing phone screens could become commonplace, eliminating the frustration of cracked screens. Flexible electronics could benefit from self-healing properties, increasing their durability and longevity. In medicine, self-healing materials hold immense promise for implants and drug delivery systems. Imagine biodegradable implants that release medication as they heal, providing targeted treatment with minimal invasiveness. Self-healing materials could revolutionize healthcare, leading to more effective and less invasive treatments. These examples merely scratch the surface of what self-healing materials can achieve. As research progresses and costs decrease, we can expect to see these materials integrated into even more aspects of our lives, making our world more durable, efficient, and resilient. Section 5. Obstacles on the road to recovery. Despite the immense promise of self-healing materials, several challenges must be addressed before they become widespread. Scalability is a significant hurdle. While researchers have successfully created self-healing materials in laboratory settings, scaling up production to meet industrial demands can be challenging and costly. Cost remains a major barrier to widespread adoption. Self-healing materials often involve complex manufacturing processes and expensive raw materials, making them less economically viable than traditional materials in many applications. Healing efficiency is another area that requires further research. While some materials exhibit impressive healing capabilities, others may only be able to repair minor damage or require specific conditions to initiate the healing process. Addressing these challenges is crucial for unlocking the full potential of self-healing materials. Research efforts are focused on developing more cost-effective manufacturing techniques, improving healing efficiency, and expanding the range of materials with self-healing properties. Overcoming these obstacles will pave the way for a future where self-healing materials are no longer a novelty, but a fundamental component of a more durable and resilient world. Section 6. The environmental impact of self-healing. The development of self-healing materials aligns with the growing need for environmental consciousness. By extending the lifespan of products and reducing waste, these materials offer significant environmental benefits. Traditional manufacturing processes often consume considerable energy and resources. Self-healing materials, by virtue of their increased durability, have the potential to reduce the need for frequent replacements, thereby decreasing the overall environmental footprint associated with manufacturing. The extended lifespan of products made with self-healing materials also translates to less waste generation. This is particularly significant for products that are difficult or impossible to recycle, such as electronics and certain construction materials. However, it's essential to consider the entire life cycle of self-healing materials to assess their true environmental impact. The production of some self-healing materials may involve toxic chemicals or energy-intensive processes. As research progresses, the development of environmentally friendly manufacturing methods and the use of bio-based or biodegradable materials in self-healing applications will be crucial for maximizing their environmental benefits. Self-healing materials represent a significant step towards a more circular economy, where products are designed to last longer and resources are used more efficiently. By embracing these materials, we can contribute to a more environmentally friendly future for generations to come. Section 7. The future of self-healing, smarter and smaller. The field of self-healing materials is advancing, driven by nanotechnology and AI. These technologies unlock remarkable capabilities in self-healing materials. Nanotechnology enables enhanced self-repair properties. Scientists manipulate materials at the atomic level for better control. Self-healing nanocomposites repair damage at the nanoscale. These materials are crucial for electronics. AI analyzes data to identify optimal materials and can create adaptive self-healing systems. In the near future, materials will be developed which can adjust their healing response. Self-healing materials are revolutionizing industries and enhancing durability. Imagine bridges that repair themselves and medical implants that heal. These materials adapt, evolve, and promise a robust future. Embracing them means embracing a forward-thinking mindset. Let's work together to unlock their full potential. Thank you for watching. If you enjoyed this video, please leave a comment and let us know your thoughts.